All right, so last video we saw the use of the um, acid chloride. Since it was so reactive, it is a very useful synthetic intermediate. So it's very useful to understand how to make them. All right, the easiest way to make a acid chloride is by using a carboxylic acid. All right, carboxylic acids are very common in nature. They're found in a lot of natural products. They are relatively what we call shelf stable. Right, you can store them in a stock room. They're often in powdered forms, crystalline, very easy to handle. All right, so we can transform them quite easily using a reagent we saw last semester. And that reagent is thionyl chloride. All right, so SOCl2. And what we saw this thing do last semester is it would swap out an OH group on an alcohol and activate it by making it an alkyl chloride. And that's exactly what happens here. All right, so we're not going to go through the mechanistic steps for this transformation. It's very similar to the one that we saw last semester when we activated an alcohol with thionyl chloride. But nonetheless, it's a very important reaction to have in your toolbox for synthetic transformations. All right, because now we've taken something that is relatively not reactive in nucleophilic addition elimination and made something that is extremely reactive in nucleophilic addition elimination reactions. All right, so for example, the synthesis of the molecule DEET. Right, this is a commercial product that is used probably starting now and throughout the summer. It's a mosquito repellent. Right, it's what we call a spatial mosquito repellent. The mosquitoes fly near this volatile compound and it irritates them and they just fly away. All right, so DEET is something we actually used to make in the chem lab. And unfortunately, you guys aren't going to get to do that this semester. But nonetheless, it's a neat compound that is made from an aromatic carboxylic acid. All right, and there is a methyl group in the meta position. All right, so the way this is done is we take thionyl chloride in the first step, and the acid is converted to an acid chloride. So now we can react this acid chloride in a subsequent step, which I'm going to do on the next slide here. With an excess of an amine called N,N-diethylamine. All right, so that looks a little funny. Let me clean this up a little bit. If we look here, the nitrogen has two ethyl groups on it, all right? And then, so we call this N,N-diethylamine, and our nucleophile is going to be the nitrogen atom, all right? So the nitrogen atom is going to attach to the carbonyl carbon. So we no longer have chlorine there, but now we have nitrogen. And nitrogen is going to bring its two ethyl groups with it, all right? And what happens to the H? Well, it winds up with the chlorine. All right, so we make HCl, but we have to be a little bit careful in this reaction. HCl is an acid, and an amine, this diethylamine, is a base. All right, so they'll react with each other. So we actually need an excess of this guy. All right, we need a large excess of the amine to react with any HCl that is produced during this reaction. And right here, this guy here is our molecule DEET. And I'm going to ask what kind of functional group does it contain, or what kind of carboxylic acid derivative did we just make? All right, so the way we identify that is you look at the carbonyl and you ask what's attached to it, a nitrogen, all right? And then on the other side, an R group. So this is an amide. All right, so we've just made an amide. So let's break this down into a two-step scheme. We had a carboxylic acid, and we did two-step reaction where we took thionyl chloride and then an excess of N,N-diethylamine. So what did we create here? The amide. So this is a very old-fashioned but still widely used and very effective way to make amides. All right, amides are extremely important in biological compounds. They form the backbone of proteins. It's an extremely robust bond. The amide bond is so. Knowing how to make amides is a very important business, and this is one way to do that by taking a carboxylic acid, activating it with thionyl chloride, and then reacting it with an excess of your amine. All right, so that is one way to form an amide. All right, another interesting reaction is when we take a look at these anhydrides. Right, we saw anhydrides as being quite reactive on our list. So what we can do with anhydrides is we can react them with something like methanol. All right. So when we look at this, we're seeing a typical nucleophilic addition. All right. So what we're going to do is we're going to say, all right, well, here's my nucleophile, the oxygen right here on the methanol, but which carbonyl is it going to attack? All right. Well, in honesty, both of these R groups are the same, so it doesn't matter. So here, we're going to look at that. In more advanced courses, we look at something that are called mixed anhydrides, where you have to guess which carbonyl is more electrophilic, but we're going to spare you from that in this course. All right, so here, we just added our methanol. All right. And what we're going to do next is have some sort of base coming by. It could be another methanol molecule. Might as well just draw methanol. Just going to pull this proton off. Now have a neutral oxygen there. All right, and there's our tetrahedral intermediate. Looks really, really bulky, but it's not bad. You just got to keep up with all your atoms. All right, and what's going to happen next is our tetrahedral intermediate is going to collapse. And since we're not an acid, our leaving group does not need to be protonated. And we're going to kick off that leaving group there. All right, so we see the oxygen, the O minus, collapsing again, and it's going to kick off our carboxylate. So this is the conjugate base of a carboxylic acid, which we said was a relatively weak acid, but it still has a very good leaving group. All right, so on the other side, let me see if we make sure I'm drawing it correctly. We're going to have our ester. So we get ester and carboxylate. All right, so let's recap. We take an anhydride and we react it with an alcohol, like methanol. We're going to get a carboxylate. Plus an ester. Where do these things come from? So if we look at our CH3O, that's what attacked, and it's right here. And this was our leaving group. I'll put in green. All right, so we swapped the blue out for the green. So blue is in and green is out. All right. So we swapped it out, and what did we get? We got a carboxylate and an ester. All right. So those are the reactions that you'll typically see for anhydrides and carboxylic acid derivatives. All right. Next thing I want to look at are some reactions of esters. All right. So esters, they don't have the best leaving group. All right. But what we typically will see with esters more than anything is something called hydrolysis. All right. So hydrolysis of esters we saw in the previous video is where you take your ester and react it with water. Nothing's really going to happen in this reaction, to be honest, because, you know, the leaving group is so bad, right? We need the OR group to leave, and under neutral conditions, an OR minus group, you know, that's just not going to work. So what we want is some acid catalyst. So as soon as you add a little bit of acid, boom, this thing's off for the races. And what we're going to get is a carboxylic acid and an alcohol. All right. So where did these guys come from? All right. So the OR was protonated and left as ROH. All right. And it was substituted by the water. All right. So the OH group went on to the carbonyl that I'll put in yellow. So that's here still. And this water is what added there. All right. So hydrolysis of an ester, by definition, hydrolysis of any carboxylic acid derivative group is going to be, sorry, I lost audio there. By definition, any hydrolysis of a carboxylic acid derivative gives you a carboxylic acid. So we're showing that here. All right. Another reaction that occurs with esters is going to be something called transesterification. And this isn't typically what I'd consider a useful reaction. It's more of a nuisance or something that you just need to be aware of. All right. So if we were to take something like ethyl acetate, which is a very common ester, all right, where is its leaving group? All right, it's this OR group. If you were to put this in acid, with, let's say, methanol, now what's going to happen is you're going to get an ester that reacts with an alcohol that's going to give you an ester product. But it's not going to be the same ester, all right? Because now your alcohol that can attack, all right, isn't ethanol, it's methanol, all right? So what can happen here is we can scramble our alkoxy group and get a new ester, all right? Now, why would you want to do this? Well, there may be some case where you'd want to do this, but this is more of a warning, right? If you have ethyl acetate and you put it in acid, all right, it's probably going to react. And if it's an acid and you put it in methanol, that's bad news, because what's going to happen is you're going to make a new ester unless you wanted to do that, all right? So it's more of a cautionary tale. Don't put esters in acid, all right, unless you want them to react. So esters are not stable in acid is the point of this story. And if you're going to do it, don't use a different alcohol than the leaving group is comprised of. All right, so the leaving group is comprised of O-ethyl. All right, so if you wanted this reaction to be safe, all right, you wouldn't want methanol. You would want what? Ethanol. Right, because if you mixed in ethanol, so we go back and have our acid, and you mix in ethanol now, Well, it doesn't really matter if you swap out your O-ethyl group, because it may not be the same exact O-ethyl group from a history, but guess what? It's still an O-ethyl group. All right. So, point is, be careful if you take an ester and put it in acid, because it's going to react. But if you find yourself necessarily having to put an ester in acid, all right, make sure you've got the right OR group as your alcohol solvent. All right. Okay, that is the end of this video series. There'll be one more, and then we'll finish up for the day. Thank you.